Hello everybody, and welcome to Part 9, revamping our game, The Player. In this video, what we're going to do is we're going to visit the game that we made in Part 5, and we're going to apply what we've learned about sprites in bitmaps to our game to give it some pizzazz, make it look a little bit better. It's also exciting because you can see here I have fixedbyproximity.com listed as at the bottom there. I finally got off my duff and got some web space, and so I have the name there. Alright, so what I have open here is the code that you should have at the end of Part 5. Alright, and I'll run it here for you, and this game certainly looks familiar, I would assume. And so this is our Part 5 game in all of its glory. Okay, before we dig in and start updating this game, I want to come over here to our objects.h, because this I did already update, so I apologize that I did some work off the screen, but I'm just trying to keep these videos from getting way too long. And you'll see that all I've done is I have taken what we have learned in our previous videos, and I've put it here in our sprite structs. So I have struct spaceship, and the only thing different is I have our animation variables in here, with a new one I'll talk about called animation row. That one only exists for spaceship because I'm using it in a special way. So animation row, we'll cover that when we talk about drawing our image. And then you can see for comet, once again, simply just added the animation variables that we need. And then I have this new struct called explosion. And you'll see explosion just has an X and Y, a Boolean value to determine whether it's alive, and then animation information. That's it. Explosions don't move, and they don't collide with objects and things like that. So it's real simple. We're not even going to utilize the explosion till the very end, but I have it here in the objects.h so that it's done. So if you are using all of the code from Part 5, just go ahead and update your objects.h. You should know what all these variables do, so I didn't bother to do it on screen. Okay. Now, coming back to main.cpp. Okay, so what we're doing is we are effectively updating a game, the game logic that already exists. We could say maybe that was our prototype of the game, while the artists were making our images and stuff like that. And now we're going to start putting this art into the game. We're going to start to expand some of the functionality. Of course, if I want to use images, I have to include the image header file. Like so, great. And so that will allow us to do all of our imagey stuff. Perfect. Okay. And next, before I get started, I'm going to go ahead and show you guys the sprite sheet that I'm using. The spaceships that I'm using can be found at this site here, arboris.deviantart.com, and it's this sprite sheet that I'm using here. And what I'm going to do is, since I don't want these lasers or these shields or these enemies or anything like that right now, what I'm going to do is I've already opened Photoshop and I've just cut these 6 images out, and these will be the animation of my ship. So when it's all said and done, you will have a sprite sheet that looks like this. I cut them out and then rotated them 90 degrees, since it's a side shooter instead of an up and down shooter. And you can see, basically we're going to have images for backing up, so there's no thrusters, images for stable movement, and then images for moving forward, like these afterburner style thrusters pushing it forward. Alright. And so that's the image that I'll be using for my spaceship, and I just wanted to tell you guys where I got it and show you how I've modified the original sheet so that you can see exactly what I'm doing. Okay, so since we're planning on using images, we have to change our init ship function. So init ship, remember, will initialize all the ship variables, but we need it also to accept an image, so that we can associate that with our sprite struct. Alright, perfect. So we've got that there, and I'm just going to copy this just so I can change the header down below. I'm going to come all the way down here to bottom to my init ship, and I'm just going to paste this, and I'm going to do ship.image equals image. Okay. We'll fill the rest of this in here, but I just kind of wanted to plug that in while I was at it, so that we didn't get any weird errors popping up or squiggly lines or anything. Alright, great. Okay, so I need to load an image into memory, and so I'm going to create a new variable. It's going to be a type Allegro bitmap pointer, and it's going to be ship image. further down where I'm initializing my add-ons, we do al init image add-on. And just like that. Great. Then right underneath our timer, we're going to do ship image equals al load bitmap, and the name of this bitmap on my drive is spaceship underscore by underscore forest.png. Alright, and you saw that background was that hideous magenta color, so I'm going to do al convert mask to alpha. To get rid of that background, we're going to do ship image al map RGB, passing 255.0255. Alright, great. So that will load our image up. And then finally, we need to, where it says init ship here, we need to pass in ship image. Okay, so our init ship is now tied in, plugged in correctly. A little bit of maintenance I have to do is, since I created a bitmap, so we don't have any memory leaks, I'm going to do destroy bitmap. And I will pass in ship image. Okay, so now let's revisit this init ship function here, and let's go ahead and plug in all of our animation information into it. So I'm going to leave the X and the Y the same. The ID, of course, doesn't change. The live doesn't change. Speed, I'm actually going to change. The animated ship is a little bit bigger than the unanimated ship, the primitive ship. Since it's just a little bit bigger, 7 feels just a little too fast. So I'm changing it to 6. We're going to slow it down a little bit. And our bound X and our bound Y, we'll come back to that. This is going to have to change for the new image, but I'm going to show you a technique that we can use for testing to figure out how our bounding boxes should be. Okay. And then after those game-related variables, let's go ahead and start setting up our animation variables. Okay, so there's ship.maxFrame. Now this is going to be a little bit weird. You saw our sprite sheet, we had 9 images, right? 3 banking with different afterburners, 3 normal with afterburners, and 3 banking the other direction with afterburners. But I'm only calling maxFrame 3 because I don't want to cycle through all 9 of those, right? That would look silly. We instead only want to show the banking animations when we're banking, as in turning, moving left to right. And we only want to, or otherwise we just want to animate through our center. So I'm just going to set up our max frames animation as 3. You're going to actually see that we don't do any animation flipping without key inputs, but I have that max frame 3 there in case I chose at a later date to cycle, meaning cycle through the animations to show the afterburners getting bigger and smaller and disappearing, getting bigger, smaller, and disappearing. I'm doing it this way to kind of be backwards compatible, if you will. If I wanted to go back and add an animation, I wouldn't have to come back in here. So I'm setting it as max frame 3. Then I'm going to do ship.currentFrame equals 0. You're also going to see we're going to use this variable a little bit different for our ship too. So we'll get there. Ship.frameCount equals 0. Ship.frameDelay equals 50. So once again, we're not using this, but if we want to use this, we want to have a slower delay. So there's only 3 frames of animation. Anything smaller than that will cycle really, really fast and it will look kind of stupid. So, like I said, we're not using it, but in case we wanted to, it's there. Our frame width. Now this is something that's very specific to this sprite sheet I'm using. It's 46. Okay. If you're using different sprite sheets, you'll want to figure out what the width of the frames for your sprite sheet are. Mine's 46. And then I'm going to do ship.frame height. And that's going to equal 41. Once again, very specific to this sprite sheet. And I actually opened up Photoshop to figure that out. And then we're going to do ship.animation columns. It's going to equal 3. There's 3 animation columns. And ship.animation direction is going to equal 1. Like I said, we're not going to be using that in case we wanted to. And then our new one, our ship.animation row. Alright, that's going to equal 1. Basically what we're doing, and I'm going to pull the image back up here. Basically what we're doing is we're going to cycle through. So this, our middle row, means that we're just flying straight on ahead. But if I were to say hit the up key, so the ship would move towards the top of the screen, I would change my row to be 0 and start showing this image, like it's banking upward. Or if I were to hit the down key, I'd change my row to 2 and get this. And I'll show you mathematically how that ties in. Alright, so that is the initialization of our ship. Alright, I can run this, and you will see that it doesn't look any different because we're still drawing it the old way. All right. So even though we're initializing with all this extra stuff, until we actually draw it, we're not going to see any difference. So let's come on down to our draw shift function. I missed it. It's right here. Okay, so all this primitive stuff, I'm actually just going to, bam, gone. No more primitives. We're working entirely with images. So we'll create our Google variables fx and fy, and in this case, it's going to be a little bit different. It's going to be current frame modulus ship.animation columns, which looks normal. That's like we've seen before. Ship times ship.frame width. And then this is where it's going to be different. Since we're not going to cycle top to bottom, we just want to be whichever row we're in. So for instance, if I'm not hitting any keys, we'll be in row 1. If I'm pressing the up key, we'll be in row 0, like I said when I talked about the animation row. I'm just going to simply do ship.animation row times ship.frame height. That's it. That's all we need. Since we're not cycling animations, we're not automating it, we can make it real simple here. And then I'm going to do AL draw bitmap region. I'm going to pass in ship.image, and I'll do fx, fy, ship.frame width. So that's how wide I want it. And then ship.frame height. That's how tall it is. And then finally its position. Now, with primitives, our position was the exact center of the ship. What I mean by that is our 4 points of a rectangle were like x minus 5, then x plus 5. Y minus 5, then y plus 5. So the rectangles, the triangles, all of the ship was being drawn about or relative to that center point. So now, since we're drawing an image, the x and y position is actually in the upper left-hand corner of the image. So if I don't modify, if I just use my ship.x or ship.y like I have been, right, what we're going to see is that the ship is actually going to appear down into the right of where we think it's supposed to be. So I've got to do a little bit of a conversion here. So I've got to do ship.x minus ship.frame width divided by 2. That'll put us halfway into the image. And then ship.y minus ship.frame height divided by 2. And that'll once again put us halfway into the image, and so it'll draw about where we think it's supposed to draw. And I see I've made a mistake here. I need to add my flags variable. Okay, so I'm going to go ahead and run this. And now look at this. We've got our bitmap ship. Still don't have our animations or anything. You can see how we're just drawing the regular afterburner, no banking, no getting bigger, getting smaller, anything like that. So our animation isn't working yet, but we've got our ship. Okay, so unlike our automated animation, we're not going to have an update for the ship. Very much like we did in part 5, we didn't have an update for the ship. Instead, I'm going to plug the animation updates directly into the user inputs, which will function kind of like our update function. So what I basically want to do is I have a grid, effectively of 9 cells, 3 of each ship position with different afterburners. So what I want to do is, if I'm hitting the up key, I want to bank kind of the ship banks to the left. With the down key, I want the ship to kind of bank to the right. If I'm not hitting any key, I want it to stay right where it's at. So let's see how we would basically add that in. So under the move ship up, right, which means the users hit the up key, I want to do ship.animation row. You remember that animation row variable? I'm going to do equal to 0. Alright. And then I'm going to do ship.animation row. So if the user hits down, animation row is going to equal 2. What I'm going to do real quick, I'm going to comment out my update comments, just so we can test this without worrying about actually losing the game, And I'm going to run that, and we can see right here. You can see my comments responding, but since we're not updating them, they're just staying over there. So I've got my ship, my afterburner's still not doing anything, but you'll see I can bank left and right. But look at this. See how it's kind of staying in the way I left it, it doesn't reset? We'll get to that in a moment. We need to essentially write a second function that will allow that to reset. But let's finish our animation update first. So I'm going to come back down to our move ship functions, and now since my up and down changes the row, my left and right needs to change my frame within that row, or my column, if you will. So what I want to do is, if I do move the ship left, so I move towards the left side of the screen, my ship is effectively, quote unquote, slowing down, if you will, right? So what I want to do is I want to do ship.current frame, and for my sprite sheet, the 2 column, or the 3rd column, you know, because it's 0 index, 0, 1, 2, is no afterburner. So it'll look like, effectively, like he's cut his afterburners to slow down. And then for my move ship right, I'm going to do ship.current frame equal 1. Alright, 1 being that the high afterburner. So we'll run this again, and now we've got our ship. You'll see when I push forward, my afterburner gets big. You can actually see it. It's not resetting. So you can see I've got that large afterburner. When I hit left, my afterburner cuts. And so once again, so we got some slick animation there. Not convincing until we get it to reset normally. And to get it reset normally, we're going to need a helper function, like I had mentioned, and we're going to need to modify just a little bit of how we're reading in the input. So I'm going to come back up to all my ship functions here, and I'm going to do void reset ship animation. Alright. And I'm going to pass in spaceship by reference, and the variable int position. I just want one function to handle both my updates, so I add that position so I can just kind of find out which one I'm calling. And let's modify our inputs real quick here. You right now see we just have these 4 if statements, but effectively what I want to say is you can't really have the key up and the key down at the same time. Granted, in my game right now you can, but I'm just going to make it so you can't, because you know user generally wouldn't do that anyway. So what we can do is we can intelligently link these together. So I can say if, or I'm sorry, else if. So if the key is up, we move the ship up. Else, if the key is down, we move the ship down. And finally, else, all right, meaning they're not hitting up or down. We're going to do reset ship, or reset spaceship animation, and I will pass in ship. I'm going to pass in 1. Right? 1 is simply a placeholder I have, right? It doesn't have any correlation to anything in the game. 1 is just an arbitrary number that I picked. Alright? And then for our left and right, same deal. We shouldn't be able to hit left and right at the same time. So I'm going to do if keys left, else if keys right, else, and once again, reset ship animation. Let me just trim this up here. And for this one, I'm going to pass in a 2. Completely arbitrary. Great. And now let's just go ahead and write our function. Come down here after init ship, and I'll drop reset ship animation. And inside reset ship animation, what I'm going to do, it won't come as any surprise, is I'm going to reset the current frame, the current animation row of my ship. So I'm going to do if position is 1, then ship animation row equals 1. Else, alright, so if it's not 1, ship.current frame equals 0. These numbers here are dependent solely upon my sprite sheet. If your sprite sheet's different, your mileage may vary. So I'll run this, and look at this. Speeds up, then comes back to normal, slows down, then comes back to normal. Left, and back, right, and then back. Look at that. So our ship animation is good. One last thing I want to show you. I know this video is getting a little bit longer. One last thing I want to show you is I told you there'd be a way that we can check our bounding box, right? To make sure that it's the right size. This ship happens to be effectively bigger than our other ship. So in my draw ship, I'm going to add the possibility of showing our bounding boxes. What you could do is you could make this able to be toggled with a button. I'm just going to comment it and uncomment it when I don't need it anymore. Or I'm sorry, I'm going to comment it when I don't need it anymore. So I'm going to effectively draw my bounding box. I'm going to do AL draw filled rectangle, and I'm going to pass in ship.x minus ship.boundx, and then I'm going to do ship.y minus ship.boundy, and ship dot x plus ship dot bound x and ship dot y plus ship dot bound y. Alright, and then my color, I'm going to do AL map RGB. I'm going to do hideous magenta 0 to 5. Oops, just like that. And actually, let me back up. This function here we want to focus on. I don't want to just draw a magenta image over top of my ship, because I'll lose the details of the ship and I won't necessarily know where I'm at when looking at the ship. So instead, I'm going to do this. I'm going to call AL map RGB A. And that A is an alpha channel. And I'm going to pass in 100. So it's going to appear approximately 40%. It's 100 out of 255. So approximately, I don't feel like doing the math, but it's going to be slightly transparent, so we can see the ship beneath it, so we can see how we're doing. So I'm going to run this, and we're going to see, look how small that bounding box is compared to the size of my ship, right? Obviously not what we want. So we need to come back to our knit ship and make that a little bit bigger. So what I'm going to do, I've already tested this before, but I'm going to just drop in the values that I found to work the best. There's the bound x being 10 and the bound y being 12. And you'll see when we run it again, much more reasonable. Sure, the head is sticking out, but if the head is possibly going to collide anyway, it's just got to follow right up into the bounding box anyway. And we miss some of the tips of the wings, but ultimately, if the meteor doesn't hit you but gets past you, you're losing a life anyway because it's going to collide with the left side of the screen. So not that big of a deal. This, trust me, will feel about right. And we could ease that up a bit or make it a little bit bigger, but we want to be careful not to make the corner or make it too big, because then the corner will extend out in this region here, and we'll get collisions even though we shouldn't, and the user will notice those. Okay, great. Last thing I want to do is I want to come back to the comment, uncomment that out, and come back to my draw ship and comment the bounding box code out so we can't see that anymore. And the only thing left to do is play my game with my new player. Oh, I'm not very good at it. Alright, so there we go. We got all our animations. It's looking pretty slick. We got better bounding box. I stink at this game. You would think making games, I'd make a game I was good at, but I didn't. Okay, so great. So that pretty much sums up how we're updating the player. In the next video, we're going to look at updating the comet, and then we're going to look at adding explosions. And you'll see that the game actually starts to really look kind of cool by then. So stay tuned.